Okay, so let us start our second day's class. It's binary numbers. But before that, we will go through this yesterday's session all in 2-3 minutes. Okay, we started with what is computer, plain definition, process, calculates, communicates. We went through computer analogy. We said, okay, there is new definition, data, movement, control, processing data, storage, and all that. It's a new definition, it's a different perspective to these days how we explain what a computer is. We use computer, laptop, desktop, mobile, tab, and all that, and then compared with human beings, processor to our brain, keyboard, and all that to our eyes, nose, five sensory objects and sensory ears and our mouth and all that. Human beings, when you compare that speaker monitor to our face and human face, you see expressions, and then you compare RAM, primary memory, as level 3 to something what we load things as a page before our exam. We study something so that we can reproduce it, something close. It's like a pages we learn. ROM, read-only memory, it's burned memory. You can't change with program. Something like our name, we don't change our names. It's burned into our memory. And then hard disk, it's like everything is there in the book, and you can learn and you can fetch it if before exam. So it's an external memory, something like you store it, you take notes. It's something similar to that. Okay, and then we try to compare with this CPU memory to level 1, level 2, level, how is it all connected, right? Cache memory, then instruction accumulator, instruction register, program counter, we compared with the bookmark, and then accumulator as a temporary place to store. And all these things we have covered yesterday. Yeah. And then we just explain 1 or 2 cycles of fetch, decode, execute between CPU and RAM, right? RAM is primary memory, and from the what happens, CPU clock sends a signal, it's electromagnetic signal, oscillator, tuck, 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 every second. That is one, actually, it's not second, 1 by billionth of a second. That's the kind of speed these days we have, right? And we have registers, what we call as CPU registers, program counter, first address, 0, load 6, loaded, instruction register, go to RAM, and fetches 20 from location 6, and 20 is added, given to accumulator, tech program status becomes 1, then goes to program counter 1 is add 7 goes to instruction register, and add 7 means go to RAM, 7 is there is location 10, you can see value 10, and 10 is added to accumulator, then it becomes 30, tuck, tuck, tuck. Store, next is store in 6 means 6 location, it goes and store random access randomly, store randomly, which goes and stores in that 6th location, and it is 30, and then it goes on. Jump 1 in this case means go back to location 1 in the RAM, right? So it goes, and then it becomes add 7, and it becomes 40, and this goes on and on. That was the exercise we went through, and then a funny game. And most of you may be remembering, some of you actually did not practice, cannot remember, but it's similar to this register to memory, right? And then we explained about program, what happens when you write a program, and then compiler compiles into machine language, and program stored in the hard disk in some location. If it is Windows, you will see like this, right? Windows operating system. If there is something, if iOS, I don't know how exactly it is shown because I haven't worked in iOS, but in Windows operating, it is something like similar to this. And I think I missed one part when I said this. Some of you are learning Python. So instead of compiler, there you have interpreter also. Interpreter is another term similar to compiler, but the only difference is compiler, with compiler, you compiles into machine language or assembly language before the execution. Right, with the interpreter, it's a line by line translation execution same time. So when you execute, it gets translate as well as execute. So in Python and some other languages, you have interpreter. In many other programming languages, you have compiler. It does more or less similar, but slightly in different way. And I'm not going to the history behind it. There is a lot of history why compiler is used, why interpreter is. There is a lot of history behind that, for each programming. I'm not going to those kind of details. For the moment, you understand that it's something converts into programming machine language, or interprets line by line during execution, or before. So one slight difference between compiler and interpreter. I missed this part yesterday, So somebody when asked about, talking about Python, I just remembered about interpreter. That's why I included that. Yeah. And then what happens when you click a game or a Zoom application? It goes to that properties, loaded to memory, like binary language. Binary language is 11010, and loaded, application open, close application, it is removed from RAM, right? So unload from RAM if it is closed. Otherwise, it is there in main memory RAM as binary language. So binary language is a language of computer that is ones and zeros. Okay. So here the assumption is a pre-compiled program, hello executable runs. That's the assumption. It's a pre-compiled program, right? Based on that. So I'm just saying from a conceptual point of view. Now, here we talked about binary language, and this today's session is binary. Okay. So how many of you have learned binary as of now? Let me look at your faces. Manu, you have already learned binary? 1010?
I started learning binary a real long time ago. I'm pretty sure I forgot a lot of it.
Okay, yeah. And Gada, Ritesh? You can switch on the video.
Sir, no, sir. Like I haven't learned binary, but I know what binary is.
Okay, you just know that. Okay. Someone else? Someone else can speak? Okay. Anyway, so let's learn binary very fast. Right? Normally, this is a 1 month, 2 month module. So I'm covering it in 1 hour. Okay. But I'm sure you will learn this with this 1 hour. It will go through a very simple approach. All of you will learn this. Okay. A magical approach. Yeah. So what are decimal numbers? Somebody can answer this. What are decimal numbers? This you should answer. So even if you don't know, what are decimal numbers? Straightforward answer.
Numbers that aren't whole. They have like a fraction to it.
Base 10. Numbers with base 10. Yeah. Whatever the numbers which you use. Yeah. So 0 to 9, right? Numbers represented by 10 digits. Decimal numbers, not in the sense of fraction, but what I'm trying to say from a mathematical definition point of view. So of course, when you put decimal number means you the number you put 1.2. Sometimes we, in our talking terms, we call it as decimal point and all that. But from a definition point of view, numbers represented by 10 digits, 0 to 9, right, are called as decimal numbers. Decimal 10. So I think it's coming from Greek word deci, right? It means 10, 0 to 9. So that's 10 numbers, 10 digits, base 10. So a number system with base 10, with total 10 numbers. So what are binary numbers? Numbers represented by 2 digits, right? Just 2 digits, base 2. Okay, that's what used in computer. That's what we're seeing, right? We already said compiler converts a program into binary language, machine language. That's all in binary. Everything in computer is binary. That's what we learned, right? Everything is binary, 0, 1, 0, 1. Everything happens in binary. How does it happen? So we need to learn that. Before we learn that, we just learn mathematics of it, binary numbers. Let's go through the mathematics, binary numbers. Okay. Now, can you see the numbers on the right-hand side? 0 to 16, I have given an example. Okay, and corresponding binary numbers. Okay, now I'm starting sequentially for you to write it like counting. So you have first 0 and then 1. So it is similar to what is that in decimal number reaching 9. Here, decimal number 9, and here it is 1, right? Here we have only 2, 0, 1. In decimal numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it reached 9 here. Now, if I add one more, what will happen? 1 shifts here, right? And 0, it's not 10, it is 1, 0. So in binary, it is 1 0. Okay. When it is 9, you add 1 to 9, what happens? You add 1 9, it becomes 10. 1 0. That is 10. Here, you add 1, it becomes 1 0. And then you add 1, it becomes 1 1. Okay. Then you add 1, all the 1 shifts to left side because there is no other number. It is only, we represent everything with these two numbers. So 1 goes to the left side, 1 add 1, carry to next to left, and then it all becomes 0. And then you add 1, 1 0 1, tuck, add 1, add 1, add 1, goes left, add 1, add 1, goes left 1, again add 1, add 1, add 1. This is easy way of going through from the very beginning. But if I ask you to convert a decimal number, big number, to binary number, you can't do that, right? This is simple because it's the beginning, small numbers. If I ask you to convert 845 decimal number into binary, this is not easy. Then how do you really convert a decimal number into binary? Can anyone knows that? I'm asking you to convert 845 into binary number. How do you do that? This is easy because you start from 0. You add 1, this. You can't remember like this, right? You should have a proper mathematical, logical way of doing it. This is also logical, but this is incremental way.
Sir, do we take the digits like when we have 8 and then we add the 2, then like that we do? We take single digits first.
No, that is not the way. Someone has the answer? Okay, so let's learn that. If it's a very easiest thing which you are doing every day, that's why you'll think that, oh, how this can be done. This is but very easy. Okay, let's look at this. Decimal number 8 to binary. How do you do that? Divide by 2. What happens when you divide by 2? What is it? What is the answer?
4.
What is the remainder when you divide 2?
4.
No, remainder.
0.
0. You divide again by 2. What is the actual number and what is the remainder?
0.
Reminder is 0.
0. Again divide 2. See?
1 and then 0.
That's it. You got the binary. Simple. So just divide by 2. If you want to convert a decimal system into binary, means divide by 2. You get all this, carryovers, that 1 0 0. You take it, you get binary, and you repeat it. You get for any numbers. You convert 10, tuck, 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 tuck. You do it for. So I just took it for small numbers. It's for easy use. Anyway, because it takes longer time, right? So 1 0 0 1. That's 9. So you have already learned how to convert any number into binary number. Just divide by 2 till you get the last number as 1 by recursively. Whatever carryover in the right side or the balance, of in every step, that is binary. Take from bottom to top, that becomes binary. Okay, you have learned that part. Now comes the most interesting question. We are all saying binary is used inside, computer, but why? Why binary? Why not decimal number? Anyone has the answer? I can tell you this is one of the most interesting and tricky questions. Even if you go to engineering colleges for computer major or BSc, degree, yes, as computer as a main subject, this is one of the most interesting questions that you will need to think. Why do we use binary, not decimal in computer?
Sir, is it because like when we use decimal system, there are 10 digits and there can be many patterns which might be difficult for the computer to understand, and by interpreting zeros and one, the computer might respond faster.
Very good, very good. That's very good answer. That's probably precise, most precisely answer. You know, sometimes you don't get it from computer engineers, right? This is a very difficult stuff to answer, because you know what happens, we all learn, right? Learn, and then we understand that it is binary, and sometimes we forget, oh, you know, what is the behind, you know, keep questioning. But this is one of the easiest answer, I mean the right answer. And there are many other technical things also related to that, but this is the real answer. Now I will explain you to make you, you know, understand with a story. Okay, and this is love story of a king and a queen lover. Okay, and I'm taking a story here. Now this here, you can imagine one king is in love with a queen of an opposite country, so it's an enemy country, right? Then the whole, you know, the story becomes complicated, right? Do you agree with me? King one from one country, other queen in another country, and now she want to elope with this king. Her parents are not allowing, the, you know, queen's parents, they're not allowing, and there are some security guards and all that to protect her. But this king from the neighboring country want to kidnap her out of love, you know. So situation is very complex, isn't it? It's a very complex situation. Do you agree with me? Yeah. And
Yeah.
then someday this king decided, right? And both of them decided, I think we should, you know, run away from this place and go to some secured place. And this king, you know, communicated through different ideas. See, there are some problems, okay, if we do this. So he tried to put all that. Look at that picture. In one picture he said there are enemies, another picture says there are parents there, another picture somebody is watching you, and okay, we can, so that is one part. Another part, okay, we can run away with maybe some speedy cars, or maybe in some bus or in train, or in flight. There are all those options. But or maybe even you can, but you have to be careful about security guard. We can sometimes, and in the end, if nothing happens, we will have to work out, we have to run away, right? And he was trying to communicate all through a secret code through a agent, you know, sending to the queen's palace, because everywhere people will be watching. Seeing all these options, one is related to risks and challenges. Another one is this escaping option. Third one is about security. Fourth one is, okay, run away and all that. Queen got confused. It's too much of information, right? Queen got confused. So Queen said, okay, all Queen said is, okay, when you're ready, you come. So security will be out during the lunchtime, 15 minutes, 1 o'clock to 1:30, or 15 to 30 minutes, or dinner time, 7 p.m. to 7:30. That's the time security out. You come there, I'll show one white towel, right? One white towel. Then I'm ready to jump and run away with you, right? So that I'm ready for you, right? Just one signal, show up, right? This white towel, right? She will just show that. So it's easy, signal. So this law is very complicated stuff. We have included all those 10 different things, but Q in intelligence, no confusion at all. Just I'll show this white signal. That's enough. I'm ready to run. We just come there. So that information was passed through a secret agent. And then that is the signal, right? So in computer, everything goes as signal, right? And the signal is either on or off. And that is electric pulse, on or off. And that is represented as binary numbers. That can be that on off voltage. What is that voltage, right? Electric volt. That electric voltage is represented as 1 or 0, not as 10 decimal number, because it can complicate. So decision making is so fast when it comes to so much of information, and the circuitry code is just 2. So that's so fast. Decision making is fast when it comes to complex. And that's the reason, real reason why binary numbers are used, or rather on-off voltage, that particular part or signal used in signal processing. Okay, so whatever we said is the right answer. So I was trying to tell a complex story so that you don't forget it. And finally, end of the day, where it is coming, it is electric signal, right? So initially we started with the computer, you compared with human beings, and then we talked about mathematics of binary and all that, and then we are talking about electric signals. It is electric signals. Initially we said, oh, it's all binary numbers. Now we are saying it's all electric signals. You understand? It's all electric signals. You have physics, you have mathematics, you have everything here, right? And I have given you a story also. So it's all there. Now let's look at the point he mentioned regarding dividing the voltage. How much voltage you have in your computer laptop? What's the input voltage? Typical. There could be some variations, but anyone can answer. What's the input voltage? I know you can.
Volts.
That's the connection you give, 110 in US and 230 in India. I don't know how much is in UK or maybe in Middle East, but that's connection voltage. But inside laptop, when it gets to inside laptop, what would be the input voltage? You connect to basic line of 110 voltage. We all know that from there. Here it is 230, but inside, so there is some conversion happening inside computer, right? The first point, how much is that voltage? Anyone has any idea? Normally it will be given in the computer manufacturers, whichever, in some computers it's 5, in some I have seen 6 also. So 5 voltage is the input voltage, right? Okay, and this 5 volt is divided into 2 values 0, 1. Okay, 2 values 0, 1 instead of 10. So this voltage 5 volt, which is direct current, not the alternating current from the system, I mean from the electric line, actual from whatever battery, that is 5 volt, right? After converting, it is 5 volt. If it is divided into 10 decimal values, that's confusion. And if it is just 2, it's very easy, 0, 5 or 0, 1, 0, 5, 0, 1. And what happens if it is divided into, can you theoretically divide? Yes, theoretically you can divide. Voltage levels, you can divide like this, right? 0, 0.5, 1, 1.5, and then you can represent decimal number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, what I have shown you. You can theoretically do that. Okay, there is nothing wrong in representing it. But one point is the chance of error during all those calculations, chance of decision making, all that is very high. I mean, the speed of decision making is faster in binary, and the chance of error is very less. So to say yes, no, that's very fast. That's why, you know, two clearly distinct states provide. That's more reliable. So when we talk about computer, we're talking about such complex calculations. There is no chance for error, right? And there is something called parity bit and even error situation in the, binary numbers, but that's not, I'm not including that. It's a bit more complex, which you learn in the later stages. But mostly the chance of error is very less. It's completely reliable, and the circuit required is very less. Otherwise, if it is 10, more circuit is required, right? So that's the reason why we are using binary, just on off. That is nothing but voltage. On off means it's voltage, electric signal, right? So it's in terms of binary, it's electric signal, and we use that binary numbers. We learn that due to this specific reason, and we use in computers as mentioned, from a decision making point of view, from a circuitry point of view, right? That is one of the fastest way. And today, when we speak, as we speak, there is one more bit called quantum bit, third bit. It is not popular, but it is there. It has already people started experimenting and people started working with that quantum computing. It's a third bit. So 0, 1, and the next third bit, like a vector. So at the moment, I'm not going to that. So in our till now, we all have this binary numbers. We'll go with that. We will learn that. We'll solidify that. Okay, and that concludes binary numbers. Okay, this is something which you learn elaborately maybe in 2 weeks, 2 months in your school, or maybe in your +2 grade, or based on the subject you select. But I try to cover it, in a bit easier way, quick, to explain the next part of it, which is electronic gates. So we already said everything is binary, everything is IC chips, binary numbers, and all that. Now, all this is what we have used in electronic gates. All these things, binary numbers. That's why we have learned binary. Now that is used in electronic gates. So you haven't learned electronics probably. Maybe anyone learned electronics a little bit? Anyone knows gates, logic gates? Anyone learn logic gates? Can say yes or no. Someone can switch on.
No, sir.
Okay, so yeah. So in binary numbers, tomorrow when you come, one assignment. Okay, convert binary number, convert decimal number 99 to binary. Difficult one. You will do it tomorrow?
Sir, could you repeat it?
Convert decimal number 99 to binary number. That's all. Just one exercise there. Okay. So we'll see that tomorrow. Just that you have to make sure that you have understood that. Everyone should just do that and upload it into the site. Okay. Yeah. You can upload into the website, GrainEd website. Now let's go to electronic gate. Are you clear on binary numbers before I move? Are you clear how to do that? Or should I repeat? What other things I have covered?
Clear.
Okay, so I have. Yeah, please.
In the binary, we can only use divided by 2, or any other number also we can use. Any
binary means by 2, by, right? That's the meaning of it. Base 2.
Okay, sir.
0 and 1.
Okay, sir.
Okay. So if there is no further question, I'll go to electronic gates. Now you are going to design a computer. Can you believe it? I'm going to make you design computer using electronic gates sitting in this class in a simple way. If you have not learned that part, you are going to do by yourself. Of course, in a piece of paper, but you're going to do that. Okay. That's why we are learning all this slowly, like a story. Yeah. Now, electronic gates are the building blocks of a computer, right? Or chips, what you call as chips, memory chip, or that chip, this chip, it's all electronic gate. All these are electronic gates, okay? And electronic gates work on the fundamentals of binary numbers, okay? So before that, where is it? Okay. This is one electronic gate. And anyone learn this AND gate? If you know, can you?
Yes, sir.
Vinayak. Manu, is it new to you?
And when you switch 2 of the switches on, the circuit turns on, and the OR gate, when one of them is on, the others off. The circuit.
So Vinayak, you know. What about Manu?
Yeah.
You also know AND gate, OR gate, and all that. Ritesh, Angelina,
Sir, I don't know this, sir. Nand Gate.
I don't know, sir.
So this is, and means just like in our English language, and 0 and 0. That operation is called Boolean operation. 0 and 0, 0. If both are 1, 1. So both are on, that means 1, right? That is and. 0 and 0, that is 0. 0 and 1, because one is one of the one part input, one input part A is 0, you get output as 0. If both of the inputs, if both inputs of the binary numbers are 1, then it is 1. That is the meaning of AND gate. If it is on, that is in the case of circuit, if both circuits are on, then you get output as on. Okay. Isn't it easy? Very easy. Both 1. And what is the meaning of or? This or that, this or that. Just think that way. Meaning is this or that. So in two inputs mathematically here, either A or B, either one of that, if that is on or if that is 1, then you get an output 1. That's all. There's nothing more to understand. Very simple gate. Either one of both of them, yes, in that case also it is 1 because it is it is OR gate. Either one. It is either one of two inputs, A or B. That is OR gate. Agree? And then there is also NAND gate. NAND means not and. N stands for not and. Opposite of and in a way. So you see on the top there is and. NAND is opposite of and. You learned it? Easy? Anyone has doubt? Just look at the output. Everything is 0 in the top, that is AND gate. Here it is all 1. So opposite of AND. If both are 1, output is 0. 0, 0, output is 1. Reverse. 0, 1 is here is again is output. This is because it's opposite of AND. Anyone has doubt? Let me go. Let me move on.
Yes, sir, you can do.
And then NOR. Opposite of NOR. See, Boolean operation. On the top right hand side, you are seeing output as either one of the one is 1, then you get output as 1. Here, it's totally opposite of that, NOR, not or. NOR means not or. Its symbol is shown like this, A plus B on top. In mathematics, you learn that A union B and all that, right? In mathematics, there is something like that. I remember A union B, A intersection B. So and or something is similar to that. So this is, it's straightforward. Here, if both of them 0 means it is 1. It's opposite of OR. Okay. And there are a couple more gates, XOR and that is exclusive or exclusive NOR. So there is only one small change compared to previous slide. In the NAND and NOR, you have output for both 0. If you just take NAND, just observe NAND. For both 0, you have output as 1, right? So, but when it comes to XOR, exclusive OR, you can see on the middle part as turned as 1, not other parts. It's just exclusive OR. That's an, so in some cases those kind of operations are used. We'll come to that, or maybe some of the gates we may not even study at the moment because it is out of the scope of my entire session. XNOR is another gate. So all I want to tell you is there are 6 or 7, or even there is inverter. You use sometimes inverter in your house. Inverter is you give input 1, output becomes 0. A becomes A dash. In my full diagram, you can see at bottom A becomes A dash. That is inverter. Buffer is you give input A, you get output A. So total how many gates? 1, 2, 3, 6, 8 basic gates. And these 8 basic gates are used inside computer for different purposes. For the moment, you fix it, okay? But AND and NAND, OR and NOR, that's very easy for you, okay, to remember. Other things, NOT, that is inverter, is also easy. A means A dash. Buffer is also easy. A means you get output A. Inverter is easy. A means A dash, it's totally opposite. XOR and XNOR, you may not be easily remembering, but if you put OR, you can easily calculate XOR. You put NAND, you can put XNOR. So you can deduce from that. Okay. You don't need to by heart, just understand the concept like this. This is what we are going to use in, designing our computer, and you are going to do that. I'm not going to do that. I'll show one example and you will do it remaining. Okay. Now let us design gates for special purpose. Yeah. And what is a special purpose? So goal here, the goal is 10th standard school code of conduct, good certificate, digital signature by, that's the goal. You need to print the certificate. Okay. To print this certificate, input required is you need to get a signature from class teacher or any subject teachers, whoever teaching you. So what will be the gate to design a computer to print this certificate? That is my question. Can someone say this? Can someone draw in paper? I think Vinayak already attended one part of my last class, so probably others can say. Can someone say, speak out? What would be the gate? What would be the gate to design electronic gate? Which and which gate? What is that?
Is it OR gate?
OR gate, yeah. So just from that English, right? Whatever English written there, right? Or it's OR gate. It's either class teacher's signature or any subject teacher, that's fine. So how do we represent that? Very simple. So one of that, okay, you got class teacher signature. You didn't go to any, you immediately got class teacher signature. And then what? And then you need principal signature also, right? Then what happens? What do you need? Principal signature. What is the gate here? You agree with me? Both signatures together, then you got two signatures. Okay. You need two signatures and then you print the certificate. Computer is done. This is one computer, special purpose computer. But this computer only prints a certificate, nothing else. This is what you see inside realistically as electronic circuits. The only difference is those are wired and this is without electricity. Okay. This is what you can see, billions of electronic circuits, billions inside a computer. So any questions here on or and? This gate is something you understood? Any doubt in this understanding the meaning of it? Anyone has any doubt? Now I'm going to give you one tough, this is easy, I know that, because I'm telling you either this or that signature. I'll give you a tough computer design now. Are you ready for that? You can probably do it tomorrow also. You can do it and then show it to me tomorrow. Everyone understood this gate? Say yes, no. If no, you can tell me. Yeah, thumbs up from Manu. I'll stop here unless someone else speaks. Only Manu is responding. Vinayak, Angelina, yes, yes. Okay, then let's go to the next. Vending machine gives you mask. If you have inserted coin and pressed a button, what is the gate? You can tell me maybe. This is very easy. Vinayak, you're trying to answer? And gate. Yeah, coin and press the button. Okay. In a game box, you have two buttons, green and red. If you press green and red together, a gun will shoot a ball. Balls could be red or green. Press the right color based on the ball came out of that game box. You get 10 points. Can you do that tomorrow? We don't do it today. I think we can do it tomorrow. Everybody can try this exercise. In a piece of paper, you can do it in a piece of paper and take a photo and upload into the site, the same site. So you can write it down or take a photo. In a game box, you have two buttons, green and red. If you press green and red together, again, gun will shoot a ball. Balls could be red or green. Yeah. Press the right color based on the ball that came out of the game box, and then you get 10 points. So you can design a gate for this. Not for the vending machine, for this one. This is complicated, a bit complicated. So you can do that as homework assignment. In the future, you design games and all that, right? If you guys are interested in it. You'll do that, right? Agree? Thumbs up. You can do it in 5 minutes, yeah? Just 5 minutes. Okay, you just need to draw that or and, then you can do it. That's it. Okay. Print first rank 95% in 10th grade only if you score more than 90% in all subjects and you have participated in any extracurricular activities for at least 10 hours at school during the year. You can try this as well, right? Ready? Take this. Take a photo, then you don't need to write it down, and then you can write it in a piece of paper and take photo and upload it back to the site. So these are for you guys to do the logic gates. Logic gates are nothing, are the basic building blocks inside a computer, and these are just for our learning purpose. This is important that you do it so that next part becomes easier. Can I move on? Oh, I have shown this. So one part I think I have shown. Oh my God. So you do it. Let me skip from that. Okay. Now, this is a 4-bit computer in a way, a diagrammatic representation. You can see some gates here. So if you are seeing real-time chips, you will see some inputs, some kind of pins coming out from the left and the right of that. So this is something similar to that. The pins A0, B0 input goes inside, and there is a gate. You get output 1. It's actually a circuit, right? Circuit, it becomes on. You give 2 input on, you get output 1. Similarly here, A2, B2, the right hand side. That's a second one. So this is, in a way, you can say it's something which gives you 4-bit output, right? 2 bits in the left side, 2 gates, and the right side, 2 gates. You get 4-bit output. So this is actually a building block of a transistor and integrated to a chip, right? So I'm introducing new terms now. It's something called transistor and integrated into IC chip, integrated circuit chip, IC chip. So this is something like this. You would have heard that 4-bit computer, 8-bit computer, or 8-bit processor. So how does it look like, this 4-bit memory, 8-bit memory? This is how the circuit looks like, right? With some pins on the left side and the pins on the right side. So if you search it in the Google, you will see a photo similar to that, right? Now, logic gates are developed physically using transistors inside computer. Okay. So transistor is a semiconductor device. These are all new terms. Transistor is a semiconductor device. What do you mean by that? What is transistor? Have you heard this transistor word transistor? How many of you know the word transistor? How many of you know the word semiconductor? Manu, is it new to you, transistor?
Yes.
Transistor is new to you. Semiconductor, you might have heard semiconductor, right? Yeah. And Ritish, someone else can speak from a different part of the world?
So yes, sir. Like I had another meeting, sir. So I just went. I had PTM in school, so I went for something. Now only I came.
Okay, okay. Someone else. How many people we have?
Yeah.
So 10. So you might have heard transistor, right? Earlier we used to have transistor radio in 1950s. Even in my house, I think 40 years back, we used to have a transistor radio. So transistor, this gates, whatever we are going to design, you are going to design some logic gates. Those kind of what you are putting in paper, those are the building blocks of a transistor. That is integrated circuit. That's IC chip, right? That's what is the inside a computer, right? So transistor is, they are made with silicon semiconductor, and that is embedded into a chip. Oh, I'm introducing one more thing, right? Transistor made with, that's a new term, transistor made silicon semiconductors embedded into a chip. All those new terms. It's getting complex, right? Earlier we talked about binary numbers. Before that we talked about RAM, ROM. Then it is built using electronic gates, and for that we have used mathematics. And then now we are coming to physics, and now to chemistry also. Silicon. What is silicon? Anyone has?
Element.
It's an element. So in chemistry, you would have heard that, or you would have learned that, right? Silicon element. So silicon element, and that is actually used for making or that's actually a semiconductor. Okay. So transistors are made with silicon semiconductor, and that is embedded into chip. So this is a new term, and this transistor, that basic building block, this logic gates are basic building blocks, right, for transistor, and transistor is a basic building for chips, right? And chips are the basic building. We keep saying that. If you ask what is computer, chips are basic building blocks of computer. Transistors are basic building blocks of chips. These gates are basic building blocks of transistors. Okay, everything basic is binary numbers, and all those things are nothing but voltage, on or off. You see the connection? The whole thing is connected, right? From chemistry to physics to mathematics to computer, everything. This inside this computer, all these subjects are integrated. Have you thought like in this way? Have you thought this subject in this way when you talk about computer? When someone tells you about this is what the computer is all about, do you really think in this way? Now we reach chemistry, silicon element, computer, memory combined with human beings, processor, RAM. Inside RAM, we talked about logic gates, binary numbers, mathematics. Those are building blocks of transistors, building blocks of integrated circuits, and there are electric circuits and electricity. There is voltage, on, off, and it's all made up of transistor, which is silicon semiconductor. Okay, that's the integrated story. You're able to visualize that, right? Are you able to visualize the connection? And I'm going to introduce those. So I already introduced the integrated circuit chips, IC chips. And chips contain resistors, capacitors, and transistors. Transistors is also known as switch. Okay. So here, for a logical stopping, I'm basically stopping here. I will continue tomorrow because there is some time to explain this in a slightly different way, to get to the skin of it. For the moment, today's interest was more towards the logic gates. Just that you have grasped, and I didn't ask you to do it on live. For I covered a bit more than I have planned, and also some things I wanted to group logically for tomorrow, connected with silicon, semiconductor, and transistors. I will continue tomorrow, but for the moment I am stopping here at the logic gates, because this is a logical stop for me also for this particular part. For binary number, because today's focus was on binary. Okay, so I'm stopping my session today with binary numbers and corresponding logic gates. I'd like to stop it here. The remaining part, there's a different story. So I'd like to take that tomorrow itself. And I think this is the perfect logic stopping. I don't want to show you this. You have to draw it by yourself. So, okay, these are the assignments for you guys. You can note down if you haven't written it. Okay, you can design these things apart from vending machine by yourself. First project and second project as part of assignment. All you may take is 10 minutes to do this. So don't worry by seeing all this. Take a photograph and upload it. You all agree with me? Any questions? I can answer. We'll go to transistors and semiconductors tomorrow. That's a different story. So today we have covered binary numbers and logic gates. Let's stop there.